Good morning, my dear students. So, in this class, I am going to tell you about the effect of gyroscope couple on a naval ship and aeroplane. Okay. So, in the last class, we studied about the what are the different axes which are going to exist in gyroscope couple. Okay. So, if you understand those three axes and what you okay now once after understanding that, you are going to understand easy of what are the effect of gyroscope couple in a aeroplane and naval ship. Okay. So, let me understand first before going too deep in this, let me understand what are the parts of an gyroscope couple on an aeroplane. Okay, what are the different parts of an aeroplane? Let me understand. Okay, so here the front portion is called as the front portion of a plane, that is called as that propeller. Okay, and that center is called as a nose, and the here the back side is called as a rear end or tail end, and the same similarly the top side is called as a what both the side, that is called as a wings. Okay, so once you are one that is called as a wings. So in here we are going to turn the either aeroplane in the left hand direction and right hand direction. Okay, both the cases will be there. Okay, so the top view, these are the diagrams of the top view and the front view of a aeroplane are shown in the figure. We are shown here the top view and the rear end. Okay, let the engine or a propeller rotates in a clockwise direction when seen from the rear or the tail end, and the aeroplane takes into the turn to the left. Okay, when we are going to observe that this plane from the rear end and the propeller rotates in the left hand direction, that is a clockwise rotation and taking the turn left, then what is the effect? Okay, so what is the effect will be there. So these are the parts of an what gyroscope couple on an aeroplane. Okay, so these are the terms we are going to use this in this. So W is equal to angular velocity of the engine, that is radian per second. Mass is the mass of the engine and the propeller in kg, and it's in kg, that is a k is nothing but a gyration of radius in meters, and I is the moment of mass, moment of inertia of an engine and the propeller, and that formula is given by m into k square. And v is equal to linear velocity of the aeroplane, that is meter per second. R is the radius of curvature in meter. Omega is an angular velocity of the precision, that formula is given by v by r, radian per second. Therefore the gyroscope couple acting on the aeroplane is c is equal to I omega into omega p. This derivation you already derived in the last ppt. Okay, now I will tell you the what is the effect of gyroscope couple when you are going to turn the left hand direction, what is the right hand direction. Okay, so here so x dash is called as an active gyroscope couple. Okay, before taking the left turn, the angular momentum vector is represented by ox. The angular momentum is represented by ox. Let us shown in the diagram a. Aeroplane taking the left turn. Okay, so when it take the left turn, the active gyroscope couple will changes the direction of the angular momentum vector from ox to ox dash. Okay, when it is going to turn the left hand direction, the angular momentum changes from ox to ox dash as shown in the figure A. So the vector x dash is called as the active gyroscope couple. That is the change in angular momentum. Okay, so that will be perpendicular to the ox. Then thus the plane of the active gyroscope couple xoy will be the perpendicular to the x dash, and that is a vectorial in the case of in this case. Okay, as shown in the diagram. So this is about by applying the right hand screw rule to the vector x dash, we find that the direction of the active gyroscope couple is clockwise as shown in the figure, as shown in the front view of the figure in the first slide. Okay, so here in other words, the for left hand turning, the active gyroscope couple on the aeroplane in the axis oz will be clockwise as shown in the figure. So the reactive gyroscope couple equal in magnitude of the active gyroscope couple, that will be there in the normal case also, it will be act on the opposite direction. Okay, therefore to raise the nose and the tip the tail of the aeroplane will takes place in this case when the aeroplane taking in the left hand direction. Okay, so here in the case 2 direction, in the case 1, when the gyroscope couple when it is taking the turn, the aeroplane couple will be to raise the nose and dip the tail as shown in the below figure. So this is about the active gyroscope effect in the left while turning the left hand side direction. Okay, so this is the case 2 will be there when the propeller rotates in the clockwise direction when seen from the rear end, and the aeroplane turns towards the right hand side direction. So what will be the effects here? Reverse of that. So here the tail is dip and nose is raised. So in this case tail is raised, nose will be dip. So okay, so this is the main effect of gyroscope couple in the aeroplane ship. Okay, So here in the case 3, propeller takes the anti-clockwise direction when the seen from the rear end on the aeroplane turn the left hand direction. Here the Gyroscope effect will be tail will be the raise and nose will be the tip. Okay. So this is about the effect of Gyroscope couple. So in the fourth case, propeller rotates in the anti-clockwise direction when seen from the rear end and the aeroplane turns towards right hand side. When during this case, the aeroplane nose will be raised and tail will be dip. So this is about the effect of Gyroscope couple in the fourth cases. So in the all the four cases I listed here, this is very important slide. Okay, when the aeroplane takes the right turn under similar condition as discussed in the above, the effect of reactive Gyroscope couple will be the dip the nose and raise the tail of the aeroplane. Okay, so this is about the first case. When the engine or propeller rotates in the anti-clockwise direction when viewed from the rear of the tail end, the aeroplane takes the left hand turn, then the effect of reactive Gyroscope couple will be the dip the nose, raise the tail of the aeroplane. This we have to write in the examination. Okay, not for that previous, that is for understanding purpose. Okay, so now when the aeroplane takes the right hand right turn under the similar condition and as mentioned note 2 above, the effect of reactive Gyroscope couple will be the raise the nose and dip the tail of the aeroplane. Okay, so like this 4 5 will be there. So this is about the effect of Gyroscope effect in the aeroplane. Okay, now let me understand in the effect of Gyroscope in a naval ship. Okay, so before understanding the naval ship, so what are the terms used in this naval ship? Okay, the top and the front view of the naval ships are shown in the figure I shown here. The end of the ship is called as a bow and the rear end is called known as a stern or aft. Okay, the left hand and the right hand side of the ships when viewed from the stern are called as a port and the starboard is in the another side, that is right hand side direction. Okay, we shall discuss the effect of Gyroscope couple in the three cases. So first one is the steering, pitching and ruling. Okay, so just to observe the diagram, so left hand portion of the ship is called as a port, right hand side is called as starboard, so front end is called as a fore end and back side is called as a rear end, that is a stern. Okay, so effect of Gyroscope couple on a naval ship during the steering condition, what going to be effect? Okay, so steering is a turning of a complete ship in a curve towards the left or right while it move in the forward direction. Okay, so consider the ship taking the left turn and the rotates in a clockwise direction when viewed from the stern, that is stern means front end. Okay, that is a left that is the right hand side starboard. Okay, so so the effect of Gyroscope couple on a naval ship during the stern taking the left or right turn maybe upturn is similar way as for the aeroplane. Okay, so this is the block diagram of this. Here when turning the ship, these are the some turn exist will be there, that is the center portion is called as the longitudinal axis, a rotor will be there and the active axis of the reactive Gyroscope couple when it is going to turn, when it is coming back, that is called as the reactive Gyroscope couple. Here transverse axis will be exist. Okay, so this 0 to x is the angular momentum and once you turn, that is x to x is called as an active Gyroscope couple and turning x dash to x is called as a reactive Gyroscope couple with an angle of d theta. So here when the rotor of the ship rotates in a clockwise direction when viewed from the stern, it will have its angular momentum vector in the direction ox as shown in the figure, it is same ox. Okay, as the ship steer to the left, the active Gyroscope will changes the angular momentum vector from ox to ox dash. Okay, the vector x dash now represent the active Gyroscope couple and it is perpendicular to the ox. Okay, thus the plane of the active Gyroscope couple is perpendicular to the ox direction in the shown in the figure b. Okay, and its direction in the axis oz for the left hand turn is a clockwise direction. Okay, the reactive Gyroscope couple is the same as the magnitude, it will be act on the opposite direction, that is in the form of anti-clockwise direction. Okay, so in this case the effect of reactive Gyroscope couple is to raise the bow and lower the stern. So this is very important, above forward direction is the only explanation. So the effect of reactive Gyroscope couple in this case is to raise the bow and lower the stern. Okay, so that you have to write in the examination. So here the note I shown here, when the ship steer to the right under the similar condition discussed in the above previous cases, the effect of reactive Gyroscope couple as shown will be the raise the stern and lower the bow. So here I shown in the diagram. So ox is the angular momentum, so just turn the right hand side x to x dash ox dash. Okay, so this is about the effect of Gyroscope couple and the steering condition. Next one is the pitching. So effect of Gyroscope couple in a naval ship during the pitching. So pitching is a movement of complete ship up and down. Okay, in a vertical plane about a transverse axis. So this is about the complete movement of an plane, that is a ship in the vertical direction. Okay, So in this case, the transfer axis in the axis of the precision, the pitching of the ship is assumed to take place with this simple harmonic motion, that is the motion of an axis of the spin about the transverse axis in a simple harmonic motion. Okay, so here the complete ship will be moved up and down direction within some axis will be there. Okay, so that is called as the transfer axis, axis of the spin. Okay, so here some formula will be generated here, this is not required while solving the problem we are going to get. So here this is not required. So when the pitching is upward, the effect of reactive gyroscope couple will try to move the ship towards the starboard. Okay, so this is very important. When the pitching is upward takes place, that ship is going to upward, the effect of reactive gyroscope couple will try to move the ship towards the starboard. Okay, starboard means right hand side it will pull. Okay, in the other hand, if the pitching is downward direction, the effect of reactive gyroscope couple is turned to shift the towards the port side. So this is very important, this we have to write in the examination. Okay, pitching is outward means towards the starboard, pitching is downward means toward the port. Okay, so these two you have to remember. Okay, so this is about same. The effect of gyroscope couple is always given specific position of an axis of the spin, whether it's pitching downward, whether it is upward. Okay, the pitching of a ship produces a forces on the bearing which will act the horizontally and the perpendicular to the motion of a ship. The maximum gyroscope couple tends to shear the holding down bolts. Okay, the angular acceleration during pitching is given by, these are the formula while required while solving the problems on naval ship problems. Okay, so the same here in the conclusion part I wrote here, we know that the effect of gyroscope couple to occur, the axis of precision should always be perpendicular to the axis of the spin. Okay, if however the axis of the precision becomes a parallel to the axis of the spin, there will be no effect of the gyroscope couple acting on the body of the ship. Okay, in the case of rolling of a ship, the axis of the precision is always parallel to the axis of the spin for all the position, but here it will not be there, so hence there is no effect in the gyroscope couple during the rolling. Okay, so we require to we require what, longitudinal axis is always parallel to the axis of the spin, but for this case, in rolling case, we are not going to get that. So hence here we are not will be there, that is a pitching, there is no gyroscope effect in the rolling cases. Okay, so this is about the explanation about the effect of gyroscope couple on pitching, that is a naval ship and aeroplane. Okay, I hope you understand this. Thank you.